Speak to the earth, and it shall teach thee. You are listening to Brothers of the Serpent podcast.
And welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents, to Brothers of the Serpent podcast, coming to you not live from the 10 by 10 by 10 tangent cube of science, nestled amongst the dusty bones of an ancient seabed, high atop the Edwards Plateau, although the bones aren't very dusty today.
Wet.
Yeah, been having crazy storms, hail. We had hail last night, woke me up, thunder and lightning.
Yep, woke me up at 5 in the morning and pounded on the window.
Yeah. Well, we got a great show today. We're gonna go through our regular listener emails, do some communications, talk about some interesting stuff happening here at the Snake Bros Institute, and then we're gonna dive back into Velikovsky's Earth in Upheaval for part 5 of that series, which may go to part 6 possibly if we can't finish it up today. But first, let's go ahead and do space weather news from spaceweather.com. March is the best month of the year for auroras. Did you know that March is the best month of the year for auroras? It is true. A 75-year study shows that March has more geomagnetically active days than any other month of the year. October is a close second. This is due to the Russell-McFerrin effect. In short, cracks tend to form in Earth's magnetosphere during weeks around equinoxes, allowing solar wind to spark the northern lights. Also, the Comet Atlas is plunging towards the sun. Comet Atlas, or C/2019 Y4, is coming, and the sun is waiting. In late May, the dirty snowball will dip inside the orbit of Mercury, passing only 0.25 AU from the sun, or astronomical units. No one knows what will happen when the comet's icy core is exposed to solar heat at almost point-blank range. Atlas is a bit of a wild card, and there's a spectrum of possibilities as it nears the sun, says Carl Battams of the Naval Research Lab in Washington, D.C. At one extreme, it could simply crumble away in the coming weeks, and at the other extreme, it could brighten up tremendously. It has an unusually small perihelion distance inside of Mercury's orbit, which bodes well for getting those frozen gases fizzing furiously. At the moment, Comet Atlas is beyond the orbit of Mars. Even at that great distance, it is already brightening, shooting up 100-fold since the beginning of February. Currently, it looks like a fuzzy star of 11th magnitude in the Big Dipper, an easy target for backyard telescopes.
Awesome.
By the end of May, the comet could be as bright as a first magnitude star. Astronomers will be struggling to see it, however, through the glare of the approaching sun. But all is not lost, says Battams. We have a number of space telescopes designed to view objects that are very close to the sun. For instance, the heliospheric imager on NASA's Stereo spacecraft will get a great view of Atlas from mid-May through early June. The camera is very sensitive, so we might be able to observe Atlas's tail interacting with the solar wind and the outflows from the sun. There is also the Whisper camera on NASA's Parker Solar Probe, he continues. This is the sun probe.
Yeah.
We will potentially be able to view Atlas from Whisper concurrently with the stereo observations, but it would require a non-standard pointing configuration, so the operation teams are currently assessing the options. If you can't wait for May, amateur astronomers with mid-sized backyard telescopes can observe Comet Atlas now. Monitoring is encouraged. Outbursts are possible in the week ahead as new veins of volatile material are exposed by intensifying sunlight. Point your optics using this ephemeris from JPL and submit your images here. So those are links from spaceweather.com. If anybody has telescopes where they can link up to their computers, you can submit images and stuff. That would be cool. So current conditions, solar wind speed 379.8 kilometers per second, and the density is 9.7 protons per cubic centimeter.
Hey, it jumped up right when we got that storm.
Yeah, that's right.
Of course it did. Man, it'd be crazy if that comet exploded and like pieces of it smashed into the solar probe.
Yeah.
That would really suck.
Or if it actually, like, parts of it hit the sun and that causes some interesting activity on the surface.
Save us from the encroaching mini ice age.
Yeah.
Highly debated, highly controversial mini ice age. Yeah. What else you got?
So the other stuff I have is emails. What do you got?
I have a Betelgeuse update. This is from badastronomy.com, and it is a mea culpa because the writer Got it wrong.
Yeah, Bad Astronomy is a script site.
Yeah.
So that's interesting. Let's hear what he says.
This guy got it wrong. I mean, I'm kind of not wanting to read the whole thing, but I guess maybe I can. The reason is because it's a lot of talking about me and I and this because I got it wrong. So
Yeah.
I don't know. It was kind of annoying, but there was some good information in here. Well, I'll just go for it. Betelgeuse has been in the astro news a bit lately, hasn't it? Normally one of the very brightest stars in the sky, in October it had started dimming, and by January had faded to roughly a third of its normal brightness. Astronomers have known for a long time that Betelgeuse periodically fluctuates in brightness, but this was a historic low point for the star. This is one of the reasons I didn't want to read it, because we all know this.
Yeah.
So let me just skip ahead here. I got it wrong.
What did he get wrong?
This is okay. So here's what I want to say next. I was wrong. While they because he was suggesting that it was and I'm not sure if I talked about this on the show, but the idea was that there's convection going on in the star, and so magma or whatever it is comes up to the plasma comes up to the surface and then goes back down, cools off, and so it gets dimmer and brighter, and this is its 420-day cycle.
Yeah.
Okay. So he says, I was wrong. While the convection plays a role, pop-ups. That's not what's going on here, at least not in a major way. I'm embarrassed by my error, but that's mitigated a little bit by at least by the fact that what's happening inside Betelgeuse is actually pretty dang complicated and not well understood. Betelgeuse is a red supergiant, a star born with probably 20 times the mass of the sun. For a few million years, it fused hydrogen into helium in its core, powering the star. When it ran out of hydrogen, it started fusing helium into carbon. This generates a lot more energy, and the outer layers of the star responded by swelling up hugely. The star is currently well over 1 billion kilometers across, hundreds of times larger than the sun. Because of the surface area is huge, the star is extremely bright, but that energy gets spread out so much that the star cools, turning it red. What happens on the surface depends very much on how energy gets from the core to the surface, and that depends on physical conditions inside the star. The important ones are the density of the gas, its temperature, and its opacity. How easily light passes, in other words, how easily light passes through it. That last one is important. If the gas is opaque, it can absorb more energy from below, and that affects how the energy moves through the gas. Sometimes it moves via radiation, literally photons of light moving from atom to atom inside the star.
Yeah.
Under other conditions, the gas will start to convect. Hot gas rises to the surface, cools, and falls back down inside the star. But other things can happen too. Under some conditions, common inside red supergiants, the star can literally pulse with the outer layers expanding and contracting over time. Betelgeuse does this on a timescale of about 420 to 430 days. This is a well-known period that Betelgeuse has followed for centuries. When it does this, the amount of the surface area increases and decreases, changing the star's brightness. It's this change that astronomers were expecting in this last cycle. I'll note again here that in my last article I wrote it was the convection doing this. That's not correct. It's a separate process, but here's where things get odd. Why did Betelgeuse dim so much? I wrote in previous articles that it may be due to dust, and it turns out this is looking very much like the correct reason. A paper just came out by astronomers Emily Levesque and Philip Massey describing observations they made of Betelgeuse very recently. What they found is very surprising. While the star's temperature has dropped as it dimmed, as expected, it hasn't gone down by very much, probably only about 50 degrees Celsius and at most 100 degrees. That will make the star dimmer by eye, but not nearly enough to account for what was actually seen. So why did the star drop so precipitously in brightness? They postulate that it's dust. This is made of tiny grains of material created inside stars like red supergiants and in copious amounts. Some dust is made out of long molecules of carbon. Some is more silicaceous or rocky. Or some
Silicates, yeah.
Yeah. Silicaceous.
Silicaceous.
I guess. Or some aluminum oxide. It depends again on what's going on inside the star. Dust made of very small grains tends to absorb blue light better than red, but what they found is that the color of Betelgeuse isn't changing very much at all. What they think is happening is that the dust from Betelgeuse is made up of bigger grains, which are more agnostic about the color they absorb. Astronomers call this gray dust. And if the dust Betelgeuse makes has a grain size of roughly half a micron, that would explain things pretty well. And other observations of the star show it is surrounded by vast clouds of dust with about this grain size. In fact, stars like this lose a lot of mass this way, and Betelgeuse is likely far less massive now than the original 20 suns it started out with a few million years ago.
Yeah.
This might explain why in the images, one half of Betelgeuse is dimmer than the other. Dust production happens in the upper atmosphere, but it may not be global, that is, made everywhere all over the star. It's certainly possible that parts of the star make more dust than others, and that is why the image isn't symmetric. Dust from half the star was blown out, getting between us and its surface, dimming that part.
Yeah.
So he says that explains a lot, but there's still something really weird. If the dimming is due to the dust, then why did Betelgeuse start to brighten again right on time in the 420 to 430 days cycle?
Yep, that's weird.
Great question. I was wondering the same thing.
Yeah.
And I don't know why. I guess I don't know when his articles were originally written about convection, but we were talking about this, that maybe the star didn't dim at all abnormally, but it was just the dust that was thrown up in the way.
Yeah.
But if that is the case, it is odd that it's brightening up
again on its normal cycle. Yeah.
Yeah.
That makes it seem like it's not dust.
Or, yeah.
That it's something internal to the star that's happening that's more like of greater magnitude than normal. It's part of its regular cycle, but it's a greater magnitude.
But it maybe blew off extra dust, and so that was part of it. But
yeah.
I guess it could be coincidental. Or
it could be coincidence.
Like
yeah.
it's going down, right? It should be approaching the back when this began. It should have been approaching the lowest brightness point.
Yeah.
And then beginning to increase again, right?
Yeah.
After the 420, 430 days. But it did dive a little deeper. It blew off a bunch of stuff, and it just so happens that it is brightening up and the dust is clearing at the same time.
I don't know. It seems like that dust would still be between us and it.
Yeah, I think in other words, there's more going on here, and this guy feels really bad for getting something wrong, which I found kind of funny.
Because that website is dedicated to telling about how everyone else is getting stuff wrong all the time. And pointing out how they're wrong. That's why it's bad astronomy. His job at Bad Astronomy is to point out bad astronomy that other people are doing.
Okay, because multiple times in the article, I'm reading the great information. I'm like, this is good information, and then he goes back into so I got it wrong because blah blah blah. I'm like, who cares?
Yeah. It's because of the nature of his website. That's why. It'd be like the guy on sitchiniswrong.com getting something really freaking wrong about Sumerian translations.
This guy, okay. I guess his name is Phil Plate.
Yes, that's right.
Phil Plate. As opposed to
Empty Plate.
Empty Plate. Yeah. Okay. All right. But good information. So thanks, buddy.
Yeah.
What else do I got here? I think I have one other thing.
You totally missed my joke about sitchiniswrong.com.
Oh, did I?
Yeah, I said it would be like the guy at sitchiniswrong.com getting something really wrong about Sumerian translations.
Oh, okay.
He would spend a whole bunch of time apologizing because his website is dedicated to pointing out how other people are wrong, not him.
All right, so two things. We need to seriously consider alien protein shakes and giant geojaws, because this is serious new science, folks. Scientists find the first extraterrestrial protein in a meteorite. A team of scientists believes they have discovered the first extraterrestrial protein known to humanity. Using a new analysis technique, the researchers claim to have found the out-of-this-world discovery inside a meteorite that fell to Earth some 30 years ago. If the results can be replicated and verified, it will be the first protein ever to have been identified that did not originate on Earth. So, yeah, if we can get proteins out of meteorites, we need to make protein shakes out of them. Because space genes.
And then we can lift, bro.
That's right. However, this is not The paper has not been peer-reviewed yet, so we're
Yeah.
we're not sure if these scientists know what they're doing. The other story that I feel like somehow is connected to alien protein shakes is... Oh, wait, and that was... Sorry, my source there was earthmysterynews.com. And the other one is from phys.org, as in PHYS.
As in physics?
Yeah.
Yeah.
Researchers develop new explanation for destructive earthquake vibrations. And I'm not going to read this story, but the gist of it is they're trying to figure out, like, there's certain patterns in earthquake activity that they understand in terms of tectonic plates moving around. But then there's this resonance going on that they're like, where is this coming from?
Okay, yeah. Anomalous resonance.
Yeah. And they've assumed, I think what the situation is, they've assumed in the past that this is this sort of rubbing together at the fault lines, right? That's making the resonance. But now they're saying, wait a minute, it's not the rubbing together. It's that it's actually crushing rocks in the fault line. Like rocks will come dislodged, like big boulders will become dislodged, and then they just get crushed. Mm-hmm. So I was just thinking, if these are the jaws of the earth, it's just just chewing up rocks. Yeah. So
nom 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 nom. Yeah.
I just had this. I don't know. I just had this mental image of just.
Yeah. It's chewing.
Occasionally, it's chewing its cud. And from time to time, it gets space protein shakes.
Yeah.
Okay.
I had that for some reason. That reminded me, like, I up in the tower, up at the top. The tower is kind of the way it's built. I think I've talked about this before. The floor will tend to vibrate. It's very sensitive because of these. It's basically sitting on these long steel beams, and it's a concrete slab on top of these beams that are suspended over top of columns. So it's kind of sensitive. Like, I can feel it if I'm paying attention. I can feel the floor vibrate. Like, for example, when somebody is driving up and down the driveway near the house, like when they pull up, like especially when we get people out there to when we hire
roll the road.
Yes, to grade and roll the road. I can feel that. Like, it's easily felt. It's very pronounced. So they're just, it's middle of the night and I'm playing video games or whatever, and the floor just goes. And I always imagine that deep down beneath me somewhere, way down there's a huge cavern and some giant stalactite fell off the ceiling and hit the floor.
Oh yeah.
I'm just imagining
awesome.
this. What else would make this giant, this weird rumbling feeling in the floor?
It's Earth Jaws, man.
Yeah, that's right.
Lost a tooth.
Yep. All right, let's do some emails here.
What's up, everybody?
Yeah. So this guy, I'm not going to read the whole email, but this is Martin. Pretty sure it's Martin. There's the email address has one name, and then at the end he signs it Martin. But he says he has remastered. He says, last year I finished a project of going through all the available Manly P. Hall lectures and removing the background noise and clapping at the beginning and the end. So he's got a remastered versions of these old lectures.
Nice.
And he wants to share it. So, Martin, I was going to say, dude, that sounds like that should be in the Library of the Serpent.
Yeah, get on Discord, buddy.
Yeah, so hop on the Discord and, give the links. You've got a OneDrive link or whatever. If you give it to Jeff, he'll put it in the Library of the Serpent. That would be awesome because the Snake Force loves Manly P. Hall.
Yeah.
Okay, so we got some stuff here from Angie.
Angie.
She says, after listening to the past few episodes reviewing Velikovsky's Earth in Upheaval, I have been trying to imagine what in the hell could have caused all these different layers of destruction. I was remembering an episode of THC, which is that's the Higher Side Chats, with Ben Davidson, which is the guy from Suspicious Observers, where he was discussing magnetic pole shifts, and I started thinking, is there any possibility of that actually happening? It may or may not be related at all, but I would love to hear what y'all think about it either way. Once again, thank you all for all you do, bringing knowledge to the masses. I look forward to every episode of Snake Bros as well as Cosmographia. And then she has a follow-up. Yeah, I appreciate that. So the follow-up here, she says, after re-listening to that episode on the Higher Side Chats, I realized what I really wanted to hear was what y'all thought about was the idea of a complete magnetic pole flip and how the sun could be causing that, and if y'all thought it could have anything to do with what Velikovsky is describing. So, I've
been back and forth on this.
Yeah, I don't know. Will a magnetic pole flip cause enormous catastrophic stuff? I just don't know. It doesn't seem like it has to. What I do know is that in the theoretical models about this, because they do know that it seems to happen. There's proxy evidence of pole shifts, magnetic pole shifts, whatever that means. And the assumption they're making is that the magnetic pole is flipping, right? And we talked about on the last episode that a 180-degree crustal shift would also show those same proxies.
Yeah.
The magnetic pole wouldn't move at all, but the crust could move around, and then you would have this reversal in the magma in the Atlantic plate. But the point I was going to make is that in the models of the magnetic pole shift, the first thing you have is an enormous weakening of the magnetic field overall before the flip happens and during the flip. So that would we would almost completely lose the magnetosphere, which means that solar radiation, the really bad stuff that right now we're protected from, would actually reach down to the surface of the Earth.
Right.
That may not be geologically catastrophic, but it would be catastrophic for the biosphere. So the lithosphere may not have too many adverse effects from that, but the biosphere would. On the other hand, though, if we don't have the magnetosphere because of a magnetic pole shift, there's also the possibility of the radioactive heating up of the asthenosphere, which is the plastic stuff that the crust of the Earth, the lithosphere, is floating on. And so if we get enough radiation coming down through the crust and passing into the asthenosphere, some people think that it could heat it up enough to change the viscosity, which could then cause massive earthquakes. It would ease the sliding of the plates around, so yeah. Who knows? We don't really know, but could it have something to do with what Velikovsky is talking about? Possibly. I just don't think that a magnetic shift would be necessarily geologically catastrophic.
Yeah. So my thoughts on this are not really based on what Velikovsky is talking about, but I'm just thinking about the idea of what would happen? How long would it take, right? The energy doesn't just vanish. You know what I'm saying? If the magnetic pole is being weakened, there's a force driving that. So the energy is being converted to something else.
That's true.
Or if it's just like we oscillate magnetic fields of electromagnets and stuff all the time. That's how we create radio waves, because this oscillation creates a wave in the electromagnetic spectrum that then travels out at light speed.
That's right. So
you can do the same thing the other way around. You can wobble an electromagnetic field with radio waves.
Yeah.
It's the same thing as like a speaker vibrating and making sound. You can also make really loud sound and make the speaker vibrate.
Yes.
So if we were bombarded by some really high energy radio waves from space that were strong enough, they could maybe collapse the the magnetic or the magnetosphere or whatever you call it, or make it flip.
Yeah.
But most likely I would imagine that there's got to be something going on in the core.
Right.
Whatever's generating the field would need some type of energy input in order to cause the pole to flip.
Right. Unless it's a built-in cyclical thing, which is something else we talked about last time. Like you brought up that the flipping handle.
Right.
And if there's something going on in there that's magnetically related, but has that same sort of deal where there's a cycle where it just flips over on a regular basis, that may be built into the system and doesn't need any external force acting upon it.
It would be really strange to me that it would go down long enough for there to be severe problems.
Yeah.
Like it seems like it would be pretty quick. It might collapse for a little bit and then it would reform the other direction. Whatever is.
Yeah.
It just doesn't seem like it would just collapse and go away unless there was a serious.
Right. In the same nature as that flipping handle. It takes it 1 or 2 revolutions to get back onto a spinning.
Right. Exactly. Yeah.
Yeah. So, but 2 days with no magnetosphere would be bad for the biosphere. That would be bad. You would need a million power sunblock to go outside.
I would kind of be more concerned about what forces were going on internally that would cause the flip, because that might be catastrophic from the inside out.
Yes, that's true. That's true.
But as far as the this magnetic flipping having any effect geologically speaking, I don't think much. I mean, it's just like you take a magnet and put it near a bunch of rocks and dirt, and you can flip it around all day. There's just not a whole lot of There's not a whole lot of
interaction.
Yeah. There is some, but it's not even noticeable,
right,
to us.
And the fact that these proxies that they're measuring the flip with are pretty regular bands of material that are on the bottom of the Atlantic. They don't show any catastrophic. In other words, the same amount of material
going
is on
from one to the other.
Yeah, right. So it seems like,
and if the collapse was a long time, we would see that in the layers.
Yeah, there would be some material that had.
There would be like the blank tape that just had magnetic things at all different.
Yeah,
just
that's true.
Because like a blank, cassette tape. There's all these tiny little magnetic particles in the strip of tape, and they're all pointing random directions.
Right, which is why you get a hiss.
Yeah, you just get this noise. But until you apply a directed field to it, then it begins to line them all up, and then they stay that way. So the record on the Earth is about the same thing. We see them all lined up to the force coming in from the Earth's field. And if there was any significant pause, we would notice that.
Yeah. Yeah. So it's not geologically significant amount of time.
Yeah.
Yeah.
That doesn't say a whole lot for us.
Right. That still could be thousands of years.
That's true. If it was catastrophic, though, there should be a catastrophic layer.
That's right. Yeah, there should be catastrophic geological signs,
Yeah.
and I don't know. So
you have the magnetic field going one direction, and then you have all these fossils, and then you have the magnetic field going the other direction.
Yeah.
Right? But because it would have killed everything or whatever,
Yeah.
So it just doesn't seem like it would be that bad.
Right. All right. I hope that answers the question. Yeah. No. The answer is no. All right. This is a Patreon message from Kevin. He says, "Hey, Snake Bros. So you may have seen this already, but if not, check it out. It's a documentary describing the Jetty robot team's exploration of the Queen's Chamber shaft and the small space behind Gantenbrink's door. Fascinating. And yeah, I have watched that, and it is really cool. So I encourage other people to go watch it. It's easy to find. He says it's called The Dentist, the Robot, and the Pyramid. You can look it up on YouTube. But yes, I did watch the full exploration, all the video I could get of the exploration when they went up the second time and, went through the Gantenbrink's door. So interesting stuff there. Thanks, Kevin. Okay, this is from Shannon. She says that she has the Bots butt flap ad. She says, I had to
Bots
express...
as in Brothers of the Serpent.
Yeah, BOTS, Brothers of the Serpent. Had to express my thoughts in a graphic. And this is hilarious. This the fashionable and traditional butt flaps available now, $59.99. And then she's got all these pictures. One size fits all. Comes with a free, easy to understand instruction manual. Tools not required. The perfect attire for constructing megaliths. It's freaking awesome. Yeah. Awesome little graphic there.
I need to throw that one up on Twitter.
I'll send it to I'll send it to History Shift. You can put it in the video too.
Okay.
Let's see. Okay. This is from Caleb. He says, "Hi guys, long story, less long. I was looking at a map and something in Saudi Arabia caught my eye. Under the city Al Hadida, it says meteorite craters, so obviously I had to do some research. This was discovered by St. John Philby, a British explorer, in 1934. Come to find out, he was looking for a lost city called Ubar that, according to legend, was, you guessed it, destroyed by God with fire from heaven. Further Wikipediaing led me to a book titled Atlantis of the Sands about the fabled city by Ranulph Fiennes. I love it when the rabbit holes converge. From meteorites to ancient lost cities, I spent a happy few hours looking into it, and I highly recommend this. Can't get enough of the podcast. Being a farmer with lots of listening time and with Cosmographia out now, I am very satisfied. Snakes you very much," from Caleb.
Heel yeah. That's right.
That's
I
right.
said heel yeah.
Heel yeah.
It's the newest one from old Daniel. Yeah, fellow farmer.
Yeah. Okay. Yeah, this is from Joanne. Dear Shiny Ones. Not sure if you remember me, but I sent you the email after the brush fires here in Australia. You gave me comfort then and you still do now. Please call me Joe. Okay, so this is Joe. I eagerly await your podcast every week. Forged certificate of ignorance in hand and the dream of one day having shoulder rivers and a bowling pin hat. She said, oh my God, that was hilarious when you said that and I totally knew what you meant. She said a bit of background info on me. The first thing I ever looked up in an encyclopedia when I was 7 years old was pyramids, not kidding. And she gives a bunch of personal details that I probably shouldn't read on the show. So she says, I was listening to your podcast again on Electric Universe, episode 42 or 43, I think, and remembered something I had read years and years ago from David Talbot about Saturn. Then I found his presentations on YouTube a few days ago, and after seeing the bowling pin hat in the 4.5-hour movie documentary, I immediately thought of you two straight away. It's full of plasma, electric universe, pyramids, planets, why none of it makes any sense in today's theories, and so much more. I strongly urge you to watch it, please. It is incredibly interesting. I have rambled enough for today. Thank you both again for everything you do. I can't tell you how much I love your show and your lovely, happy, funny voices. Keep laughing a lot. Snakes! Warm and fuzzies from Joe.
Awesome.
We have looked into the work of David Talbot, and it is interesting. The stuff about Saturn being the old sun, stuff like that.
Yep.
Yeah, it is fascinating stuff. Thunderbolts of the Gods is what that... and she's got an aptronym also from Oz. She says, here in Australia, our New South Wales Minister of Health is Brad Hazard.
Oh, God.
Yep, no kidding, mate. Gotta love Australia. Snakes! Thanks for the acronyms. I love them. Okay, we have somebody here who's offering to build us a better website.
Oh.
So,
slam.
Thanks, guy. I kind of like my website. I really appreciate the offer, really, honestly. But, I like to have, I like the blogger because, number one, it's easy. And number two, I don't have to ask anybody any questions to get stuff changed on it. So I appreciate the offer, man, really. But no, just keep listening to the podcast. I really appreciate it. But nope, I think I'll just manage the website myself.
Yeah, Russ's internet comes from the 90s.
Yeah, one of the things he was complaining about is I don't have a mobile version. And yes, I purposefully turned it off because I hate mobile versions of websites. You know, when I'm on my phone and I get to a website and it's showing me this like weak mobile version, I'm like, no, desktop. Show me the desktop. So, because he's saying like Blogger doesn't have a mobile version. Actually, it does. I turned it off. Okay, guy?
See? He's got his ways, man. Just don't worry about it.
Okay, so this is an interesting one about the olive trees from Jason. He says, yo, love the show, especially these Velikovsky episodes. He got a bad rap, but he was right about a lot of shit that we haven't caught up to. Anyway, I love the stories from the farm, and I hope you talk about that more. I love trees. I am a fledgling bonsai artist. Oh. That said, you might be sitting on some priceless material from what I heard in the Earth and Upheaval Part Forecast. Great one, by the way. Trees in bad shape can be like diamonds to us, to the bonsai people. Good raw bonsai material is hard to find, and if you have some, you could make some serious bank. But more importantly, make some people really happy and give some hopeless trees a new lease on life. Maybe there aren't any diamonds. Maybe they're all great. I don't know. But if you want, I can tell you what to look for, and I can look at some pictures. I could also come down and get some trees. You probably would not recognize the value as we look for very weird, counterintuitive qualities. I could help you with that. The olive trees you described growing up from the base sound like great potential. Please reach out and maybe we can give some dying trees a second life. One last thing, I commented a while back about the wing nut, the Russian cosmonauts flipping it over and it resumes its rotation. Anyway, I'm glad you guys brought it up in your podcast. I think that is what happens. Seriously, please hit me back about the trees, fellas. Thanks, Jason.
Yeah, so I have noticed that the leaves get smaller.
Yeah.
The leaves.
It would be awesome if he could make little olive bonsai trees.
Dude, that would be freaking awesome,
really
buddy.
Cool, yeah. Yeah, man. I don't know.
So the question is, do they need to be kept in this situation that they're in where every year they freeze back down, because like I'm afraid ultimately that would kill even the efforts of making them a bonsai tree? Or do they need to be taken out of that situation? In other words, do we need to go dig them up, or can we actually just keep working with them, and the freezing back, they'll actually harden off to that eventually as they become bonsais, I guess is what I'm asking.
Yeah. I don't know. It'd be cool. We could take some pictures of them and send them to him. That's what he said.
Yeah, well, right now they just look like dead trees, buddy.
Yeah.
But yeah, in the spring, when they, whatever we see where they're coming back, we can take some pictures. But they come back like a bunch of suckers down at the ground.
Yeah. Man, I totally got discombobulated. The bank just said that my card is shut off again.
Oh, God.
Dang it. Let's take a break.
Those freaking dirty snakes.
Yeah.
Getting trolled by a Grimerica podcast. Brothers of the Serpent podcast, the finest 2 hours in podcasting.
Audio quality is certainly the finest. Maybe not the content, but the quality, yeah.
Yeah. We don't use gates.
Right. Darren.
Precious gates. Yeah, we have fancy mute buttons now.
Yeah.
And they work. Yeah, so a couple more listener things.
Yeah, this is a pre-show.
Snake Force pre-show.
Yeah, Snake Force pre-show troll chat on the Discord. So everybody should join the Discord. You can go to the website, brothersoftheserpent.com, and on the right there, click on Snake Pit Discord chat, and that will take you to a page where there is a little widget where you can see all the members that have joined, and there's a connect button down there. People have been saying the link doesn't work. Well, that link doesn't take you to the Discord. You see the widget, and there's a connect button at the bottom of the widget. So just for clarification there. Okay, so this one, I'm not sure how to say the name, of course. It looks like inimical to me, but he says, could CMEs be responsible for the vitrification of some ancient stone structures like what we see in Peru? Or are there any better explanations?
No idea. Are they really that hot?
Right. So that's what I said. And I had this weird habit. I'm like, yeah, give us trolls for the show. And then I start answering the questions in the chat, which is not what I'm supposed to do. But yeah, so I basically was saying, it seems to me like that air bursts are, bolide bursts in the air are more likely to cause vitrification.
They can make nanodiamonds. Yeah.
And CMEs are mostly a magnetic and radiation event as opposed to heat. The Carrington event didn't melt stuff. It melted things, telegraph wires, not because of heat, but because of EM fluctuations that caused overloads in the wire.
That heated up the wire due to the resistance of the wire to the electrical flow.
That's right.
Yeah.
So like the Carrington event, nobody's faces melted, no buildings got heated up. It didn't raise the temperature. It just caused massive EM fluctuations.
Yeah.
So CMEs are giant, planet-sized clouds of basically invisible solar plasma that has had 93 million miles to cool down by the time it gets to us. It's mostly connected magnetic lines. It isn't necessarily going to heat up the Earth. I don't think. Don't quote me on that. I suppose huge solar flares with lots of that caused a massive burst in.
Well, there's the idea that. I'm interrupting. Sorry.
Well, no, it's all right. And increased. In other words, if we had a series of flares and bursts on the sun that resulted in increased insolation, meaning solar energy into the atmosphere, in terms of light energy, that could warm things up. But I just don't think that it would be melting rock on the surface.
Rocks, yeah, I was thinking about like massive amounts of dust from, a close pass by a comet or something coming in at really high velocities and burning up.
Yeah,
so
that's
just like this huge thick cloud of dust burning up in the atmosphere,
Right.
and the whole atmosphere basically just catches on fire.
Yeah, and it throws like a giant heat wave down to the surface.
Right,
Yeah.
or the other thing would be, and still that would be questionable. Can it get hot enough to do that to rock? But the other thing would be like oblique impact.
That's right. Yeah.
So like this impactor basically ricochets off, or just travels through the atmosphere.
Right.
Doesn't actually make
Exploding and ablating the entire time.
right.
Yeah.
That's like running a torch across the earth, basically. So that
Yeah.
could do it.
Good point. Great point. Okay, another question. This is from History Shift. Any thoughts of doing another not live show in here?
I have been thinking about that.
Yeah, we have.
I've also been thinking about doing the first segment.
Yeah,
Live, not
that's
live.
true. Yeah, we can.
And
do
then
the
just
first
be
segment.
like, GTFO, guys.
Yeah.
Boom.
Hang up.
Feed killed.
End of show for you guys.
That way you wouldn't have like, post live show depression, because like when it comes out the next day,
You're like,
you've
I've
already heard it.
this. Yeah. Well, and the other thing I thought of is like right now our schedules are having us do the show in the middle of the afternoon when everyone's at work. So
Yeah.
I basically said, we'll probably, but we probably won't do another live show until we're doing a show in the evening time when,
That's a good point.
So
yeah.
right now we're doing them at 3:00 in the afternoon because of the way the schedules are working out and not working out, because as you guys have noticed, the watcher isn't here. So some schedules aren't working out despite all the machinations that we do to try to make them work out. Jeff says, I've been a little busy lately, so I haven't been super active in the chat, but lots of love to everyone. I can't wait for the new sode. Thanks, Jeff.
So
Yeah, that's the Frank speak. And there was one more question. This is from Meese. I think that's the plural of moose, right?
yeah.
He says, hi, Snake Bros. Have you read Stargazers and Gravediggers, Memoirs to Worlds in Collision?
No.
No.
Sounds
I have
cool.
not. Yeah, sounds interesting. I have read the
Star Diggers and Grave Gazers. Sounds like a cool book.
I have read the Velikovsky Heresies, which is Laird Scranton's take on Velikovsky's work. That's what this sounds like. Memoirs to Worlds in Collision sounds like a follow-up, somebody else's follow-up to Velikovsky's work. But yeah, no, I haven't heard of that, so maybe we'll check it out. Okay, I think that's it.
Okay.
Ready to go back into this
Let's
book?
get in it.
All right, Immanuel Velikovsky's World in Upheaval.
Earth in Upheaval.
Earth in Upheaval. Yeah, I got the names mixed up there. Okay, so the last thing I was reading, we were talking about it's basically the energy paradox of all these people, these scientists, mathematicians, astronomers and stuff pointing out that to have a proper ice age, you need lots of heat.
Right.
In order to move the water from the oceans to the poles.
Right.
So that's where we were. And the last thing I read was about the collection of ice at the poles that resulted in these enormous ice ages seems to be timed at the same time when we have enormous torrential rains elsewhere in the world that caused Lake Bonneville, for example, which was, the Great Salt Lake now, which is enormous, is a tiny, tiny, tiny piece of what was once this absolutely gigantic, almost like an inland sea. Bonneville was humongous, caused by torrential rains that were simultaneous with the glacial periods in higher latitudes. So, a working hypothesis. Let us assume, as a working hypothesis, that under the impact of a force or the influence of an agent, and the Earth does not travel in an empty universe, the axis of the Earth shifted or tilted. At that moment, an earthquake would make the globe shudder. Air and water would continue to move through inertia. Hurricanes would sweep over the Earth, and the seas would rush over continents, carrying gravel and sand and marine animals and casting them on the land. Heat would be developed, rocks would melt, volcanoes would erupt, lava would flow from fissures in the ruptured ground and cover vast areas. Mountains would spring up from the plains and would travel and climb on the shoulders of other mountains, causing faults and rifts. Lakes would be tilted and emptied, rivers would change their beds, large land areas with all their inhabitants would slip under the sea, forests would burn, and the hurricanes and wild seas would wrest them from the ground on which they grew and pile them branch and root in huge heaps. Seas would turn into deserts, their waters rolling away.
Mm-hmm.
So he's painting a picture there, basically harking back to everything we've read in the book about mountains rolling over top of other mountains and all these marine animals on top of, on top of the continents and very little sediments down in the oceans, enormous lava flows that didn't come from any volcanoes and so on and so forth. So I think that's it. He does this occasionally throughout the book. You read all this stuff and he's giving you all these details and all these scientific quotes, and then he just paints the picture.
Yeah.
And that's when you're just like, holy crap, this is crazy. Okay. So we're skipping ahead a bit in the book here. So he says, all this created scenes of the utmost complexity. One example is the old but not antiquated description of the northeastern United States from Maine to Michigan and New Jersey by J.D. Whitney, professor of geology at Harvard from 1875 to 1896. In his work, The Climatic Changes of Later Geological Times, he wrote about this area as, quote, a region where the glacial phenomena exhibit the highest degree of complexity. We are beset with difficulties when we attempt to solve the problem presented by the northern drift in northeastern America. Extreme complexity in the direction of the striation, proof of the former presence of the sea over a part of the region, and of fresh water over another extensive portion, enormous accumulations of detrital material evidently deposited by water, occasional peculiar transportation of boulders in a manner not in harmony with anything we see ice doing at the present time, occurrence of linear accumulations of sand gravel and boulders closely resembling the Ossar, which is Scandinavian crests of drift, in character. Proofs in some part of the drift region of the prevalence during the glacial epoch of a colder climate and in others of one warmer than that now existing. These are just some of the difficulties which must be met by those who undertake to solve the problem of the northern drift of northeastern America, unquote.
Yeah, there's like a really good point in there about the uniformitarian problem.
Yeah.
It's like, how do you move this massive erratic one piece of boulder at a time? You can't do it.
Right.
And we're not observing that. I mean, we are, I'm sure there's erratics being moved by boulders at this, by glaciers at the time, but
yeah,
nothing of the size that we see laying around.
Right. And
like some of those huge ones.
Yes, that's right. And as Randall points out, in a lot of cases, the deposition of these sand gravels and other stuff is not ice related. Mm-hmm. When you see like these valleys, like a river valley, and it's sharply cut, and then there are these very nicely sloping ramps of similarly sized material on the very edges. The fact that all that material is roughly the same size as all the rest of the material points to water deposits as opposed to ice cutting.
Glaciers don't size sort.
Right.
Yeah.
They don't care how big or small it is.
Right.
But that it is easily explained by the fact that water at the edges of any channel is going to be moving slower than the stuff in the middle, so it drops its sediment loads there. I thought that was one of the best points that Randall made, like that changed the way I see river valleys.
I just want to I want to have a GoPro camera down in the bottom of that, massive river flow that's tearing out.
Yeah, picking up stuff.
That's tearing out the whole Colorado Plateau.
Yeah.
And just be watching these massive boulders just rolling along the bottom.
Yeah.
That'd be so crazy.
Yeah. Stuff that you'll never be able to see.
I know.
You have to put that in that list. Because even if it started happening, you still couldn't see it.
I know.
Okay, the theories of warm interglacial periods and of the deformation of land and its submersion as the result of the removal of the ice cover could explain the puzzling phenomena in some cases, but in many others they could not do so. Thus, bones of seal and walrus are found in Holderness, Yorkshire, with freshwater mollusks of warm climate. Quote, despite its anomalous elements, the deposit is classed as interglacial, unquote. And similar strata in Yorkshire, hippopotami are found as well. So you've got hippopotami, mollusks, and seal and walrus all found in the same deposits. The mollusks, by the way, are freshwater mollusks of warm climates. Seals and walrus are cold marine animals, and hippopotami are like tropical land animals. So what is going on?
Throw it all in a blender.
Right. The glaciers in the Alps served as observational material for deductions concerning the continental ice cover. However, alpine glaciers carry stones downhill, not uphill, and the general question was asked whether ice could carry rocks uphill. Erratic boulders are often found in places where continental ice could hardly have deposited them. Charles Darwin inquired and learned that erratics are found on the Azores, islands separated by the ice cover by a wide expanse of ocean. So the Azores has erratics.
I got distracted. On the, like, exposed on the land right now or down under the water?
Yeah, he says that they are found on the Azores, islands which are separated
on
by
the
ice
islands.
cover. Yeah, so they're probably under the water too, but I think that what Velikovsky is pointing at again
Because those islands just come towering out of the...
yeah,
out of the,
and so there's erratic boulders strewn up those mountainsides. Wow. The ones that haven't had a flank failure. So you can imagine that it's big waves doing this. Cumming describes erratics close to the summit of the Isle of Man amidst the Irish Sea, where only waves could have lifted them. In Labrador, boulders have been seen rammed against the slopes of the hills, which could have been done only by tidal waves. As already said, in India, in an earlier ice age, detritus and blocks were carried not from the land towards the sea, but in the opposite direction, from the sea up the Himalayas, and not from higher latitudes towards lower, but in the opposite direction. The whales in the hills of Vermont and Quebec were cast there by an erupting ocean. Yeah, and it's true. No ice cover is going to carry a whale into the mountains of Vermont.
Right. So that's what that whale was doing up the river, and
could be, yeah.
Except that the trees were all there. That doesn't make any sense.
Right, yeah.
That was a weird story.
Yeah, we also talked about, I've mentioned a couple times, the Valley of the Whales in Egypt. So in the middle of the Sahara, there's a valley, that's just desert, but it's full of whale fossils. And what's really weird about it is that we're not talking necessarily just bones here. Some of the fossils are partially decomposed, right? So in other words, you see this broken, it's broken now, but you can see that it was a whole whale body, and now it's big boulders that are sort of in a line of a whale that was still had flesh on it that was partially decomposing at the time that it was covered up and then began the fossilization process. So there's all these...
So it's like the sea left the area and all the whales got stranded there and then started to decompose, but then they were covered in sediment.
Right. Some of the fossils look exactly like beached whale decomposition.
That would be the taphonomic circumstances or whatever.
So in other cases, there are bones. There are these beautiful sets of enormous whale bones that are fossilized, but in other cases you see that there is a line of boulders of a whale that is still intact in a lot of cases. And there's like little weird dangly things because he was decomposing. Very strange.
Wow.
Yeah. Okay, so here we go. Magnetic poles reversed. Angie. In all parts of the globe, rock formations are found with reversed polarization. Paleomagnetism, almost every month, detects more areas of inverted orientation. Quote, sufficient experiments have now been made to allow only one plausible explanation of this inverted magnetization, that the Earth's magnetic field was itself reversed at a period when the rocks were formed, unquote. At the same time, it was admitted that, quote, no known mechanical or electromagnetic local effect can cause such a reversal of magnetization over an area. Mm-hmm. So we were talking about the pots last time, the quote-unquote tax jars, and you were wondering if it could be a local thing, and there's this guy saying no local effect can cause such a reversal.
But they were being fired. Like, so if they were making them out of clay...
Yeah, and it's actually in the glaze.
The clay may have. Okay, yeah, I was going to say the clay is going to be all mixed up. Mm-hmm. But yeah, if it's happening very quickly I wonder if that makes a difference.
Yeah,
I don't know.
An even more puzzling fact is that the rocks with inverted polarity are much more strongly magnetized than can be accounted for by the Earth's magnetic field. Lava or igneous rock on cooling below the Curie point acquires a magnetic charge stronger than the charge this rock would acquire in the same magnetic field at outdoor temperature, but only twice so. The rock with inverted polarity, however, are magnetically charged 10 times and often up to 100 times stronger than they could have been by terrestrial magnetism. Quote, "This is one of the most astonishing problems of paleomagnetism and is not yet fully explained, although the facts are well attested," unquote. So that may actually imply that upon a reversal, there's like this surge of magnetic power once the field reasserts itself.
I would like to see what the ideas are about it now, because this was, again,
in the 50s.
In the 50s.
Yeah.
I should look that up, but if I do, I won't be able to pay attention. Too bad we don't have the watcher.
Yeah. In a recent article, S.K. Runcorn of the University of Cambridge reports that, quote, "the evidence accumulates that the Earth did reverse its field many times," unquote. And then, quote again, "The north and south geomagnetic poles reverse places several times. The field would suddenly break up and then reform with the opposite polarity," unquote. The source of the terrestrial magnetism is supposed to be in electrical currents on the surface of the terrestrial core. Quote, "Substantial changes in the speed of Earth's rotation become easier to explain. Whatever the mechanism of the origin of the terrestrial magnetic field, there seems no doubt that the Earth's field is tied up in some way with the rotation of the planet. And this leads to a remarkable finding about the Earth's rotation itself," unquote. The unavoidable conclusion, according to Runcorn, is that, quote, "the Earth's axis of rotation has changed also. In other words, the planet has rolled about, changing the location of its geographical poles," unquote. He charted the various positions of the North geographical pole. The next question then is, when was the terrestrial magnetic field reversed for the last time? Most interesting is the discovery that the last time the reversal of the magnetic field took place was in the 8th century before the present era, or 27 centuries ago. The observation was made on clay fired in kilns by the Etruscans and the Greeks. So here he's talking. This is where I heard about this. I was wondering, I'm like, where did I get this? Oh yeah, it's from this book. "The position of the ancient vases during the firing is known. They were fired in a standing position, as the flow of the glaze testifies. The magnetic inclination or the magnetic dip of the iron particles in the fired clay indicates which was the nearest magnetic pole, the south or the north. In 1896, Giuseppe, can't say his last name, began his careful studies of the Attic or Greek and Etruscan vases of various centuries, starting with the 8th century before the present era. His conclusion was that in the 8th century, the Earth's magnetic field was inverted in Italy and in Greece. Italy and Greece were closer to the South Pole than to the North Magnetic Pole." P.L. Mercaton of Geneva, studying the pots of the Hallstatt age from Bavaria, which is about the year 1000 BC, and from the Bronze Age caves in the neighborhood of Lake Nechutel, came to the conclusion that about the 10th century before the present era, the direction of the magnetic field differed only a little from its direction today, and yet his material was of an earlier date than the Greek and Etruscan vases examined by the other guy, whose name I can't pronounce. But checking on the method and the results, Mercaton found these perfect. An ancient vase found by F.A. Forel in Boron des Morges on Lake Geneva was broken and its pieces were scattered and lay in all directions. When assembled, they all showed one and the same magnetic orientation, which proves again that the magnetic field of the Earth was unable to change the orientation originally acquired by the clay when it was fired and cooled.
Yeah, so assuming that the pots were fired where they think they were on the Earth.
Yeah, that's true.
The magnetic pole, it is drifting right now, and it's drifting further away from the northern axial pole.
Yeah.
So it's possible that it could drift far enough if it was going in a direction that was away from Europe, that the southern pole, like it could go far enough to where the southern pole, the magnetic pole, would actually be closer to Italy and Greece than the northern magnetic pole.
Right, because the northern magnetic pole would end up actually on the other side of the planet.
Yeah, it would be moving south, and the southern pole would be moving north.
Yeah. Yeah. And that's interesting because now that I'm thinking about it, what is the pole doing? Because the actual northern axis, right, is stationary. Yeah. You know, I mean, okay, so the axis itself wobbles. We have
but
perception.
it doesn't wobble in reference to the crust.
Right. But what's interesting is that that this magnetic pole that's moving around, if it's staying in Siberia, roughly, then that means it's having to orbit the axis once every day. That's interesting.
Right.
So what's going on in the interior crust that's allowing it to orbit the axis once every day? That's weird.
Is the idea that the interior rotating faster than the exterior?
Yeah,
Does anybody know? Is there any?
I don't know. There's this idea that the core is composed of two parts. There's a solid nickel iron core, an inner core, and then the outer core is liquid nickel iron, some kind of metallic liquid, and that stuff is hot and spinning and flowing around that solid inner core. Now, is the inner core rotating? It must be. But is the outer core spinning faster? And it's that motion between those two
like
different...
this drag or something like that.
That's that motion between those two metals that's causing the electromagnetic field. I don't know.
I don't know. But I guess the idea is that technically you could imagine a gradual drift of the magnetic poles all the way to 180 degrees. Like, why is there some reason they couldn't do that? I mean, we already see that they are drifting away from north and south.
Yeah.
So
no, I guess not. The fact that they're able to wander like that seems to imply that that there could be a scenario where it ends up near the equator for some reason. You know, that would imply something really strange going on in the interior, I think.
Yeah. It seems like the physical stuff in the interior would need to do the same thing. There would need to be motions in the interior that would end up resulting in that kind of magnetic field, which is weird because usually you get a field with an axis, and the axis is an angular momentum kind of axis, right? It's perpendicular to the direction of the rotation. So, yeah. Well, let's take a break. Right. Well, hold on. I am really interested in magnetic fields around molten metal because that's just really strange to me.
Yeah.
I feel like I'm familiar with the idea of magnetic fields on crystallized, like solid state.
Right. So I think the difference here is that because we know that like steel in regular atmospheric pressure at sea level, once you get it up to 600 or 700 degrees, it loses its magnetic field.
Right.
It ceases to. But
because all of the particles are so active, they're bouncing all around, and there's so much activity that it's chaotic.
Yeah, but this stuff down under the earth is under so much pressure that it's still crystalline, even though it's liquid. Is the idea?
That's crazy.
Yeah, it's really weird.
Weird.
Mm-hmm. Yeah, it's very strange. But
so the magnetic, I guess, the magnetic field's interaction with the crust could also is going to have some type with the solid materials in the crust. Obviously, all of these tiny little things are aligning. Right?
Yeah.
So there's an interaction there between the magnetic field and the crust, and so all of the solid material on the exterior.
Yeah.
Now, of course, that's maybe far away from the source, so inverse square law, it maybe not be that strong.
But the magma that comes out, once it dries, it's aligned to this field, right?
Right.
So there's an interaction.
There's an interaction.
Yeah.
So whatever's happening in the core, creating the magnetic field, it's also being affected by
that's right.
all of the crystallized magnetic materials in the crust.
Yeah.
That's having a pull on.
Yeah, to cause a drag or whatever, however you think of it. Yeah. So the Urals in Siberia has a lot of metals in them, and that's why it's pulling the magnetic pole over there. I don't know.
Okay, we can take a break.
Yeah, let's take a break. Handling all technical difficulties flawlessly.
Flawless.
0 mistakes. Here at the Brothers of the Serpent podcast and the 10x10x10 Tangent Cube of Science, where we know exactly what we're doing. Day 2 of attempting to record the podcast.
Retro causality.
We had to stop recording yesterday because of other technical difficulties, not having anything to do with the studio work that Kyle's doing. But all on my end, actually. I have an old, very failing phone, and it failed me. All the marks, the bookmarks and highlights that I had made in the book vanished for like the next 3 or 4 chapters. There was just nothing. All the marks I had made were gone. So we had a catastrophic end to the attempt to record the show, and I had to go back and go through those chapters and make the marks again, which I did. So now we're back on the second day.
Yep, and we were planning after the show to do to go back on to Where Did the Road Go with Soraya.
That's right.
And so this is one of those weird time things again where after the show we do a show with Soraya, but it's already happened.
Yeah.
Which is really weird.
Yeah. So we are going to do a show with Soraya that we already did.
That's right.
And of course, the Watcher is watching over us from his secret space station in secret outer space. He says that there's a lot of noise right there because they have a huge leak somewhere. There's a pinhole and all the air is escaping into space and they're trying to find it. But anyway,
he's in a spacesuit. He can't actually talk to us. But
he is watching, and so he is here, and we will be paying attention to what he's typing
with his space gloves. Also canceled.
All right. Volcanoes, earthquakes, and comets. Central America abounds in volcanoes, most of them extinct or dormant. The highest, Orizaba in Mexico, is over 18,000 feet high, and it was active for the last time 3 centuries ago. In the United States, few volcanoes are active, though many became extinct very recently in the geological sense. Alaska, the Aleutian Islands, the Kamchatka Peninsula, and the Kuril Islands encircle the northern Pacific with a volcanic arc. The Japanese islands contain volcanoes by the score. Most of them are extinct, some only very recently so. Formosa, the Philippines, the so-called volcano islands, one of which is Iwo Jima, the Moluccas, northern New Zealand, the Sunda Archipelago, all are crowded with volcanoes, most of them only recently extinct. In the center of this chain are the Hawaiian Islands, with 15 great mountainous volcanoes, all extinct or dormant, except Mauna Loa and Kilauea, 2 of the largest volcanoes on Earth. Quote, "How was that 30,000-foot cone built from the floor of the deep sea?" Unquote. 30,000 feet, yeah. When in 1855... Mauna Loa erupted, the lava ran over the land at a velocity of 40 miles per hour, faster than a swift horse. In 1883, when the volcanic island of Krakatoa in the Sunda Strait blew off, it sent a column of pumice and ashes over 17 miles high. It raised tidal waves 100 feet high that carried steamships miles inland and were felt on the eastern coast of Africa and the western coast of the Americas as far as Alaska. It created a noise that was heard in Ceylon in the Philippines, and even in Japan, over 3,000 miles away. This would compare with an explosion in London being heard in New York. When Bandai erupted in Japan in 1888, it cast up almost 3 billion tons of material and blew off one of its 4 peaks. But these delayed actions of single volcanoes look like child's play when compared with the forces that in past ages thrust up the Andes, spread the Deccan Trap, the great lava flows several thousand feet thick that cover 250,000 square miles in India, and built the lava dikes that cross South Africa, spread the Columbia Plateau in the Americas, and laid the lava bed of the Pacific Ocean.
Wow.
250,000 square miles. That's the Deccan Traps in India. God, thousands of feet thick. What? What kind of... you can't even call that a volcanic eruption. That's something else.
It's just... Yeah.
Iceland in the North Atlantic has 107 volcanoes on it and thousands of craters. Large and small, none of the volcanoes is geologically ancient, but many of them are extinct. The island is covered with coagulated lava, fissures, and crater formations. Iceland is one of the rare places where, in modern times, lava streams have been vomited from fissures in the earth without a crater having formed. So there's no mountain. It's just a crack opens up and lava starts spewing out of it. There's no cone. There's no...
So that volcanic eruption basically threw 521 Great Pyramids into the stratosphere.
Holy crap. New measure.
Almost 522.
Almost 522 Great Pyramids got thrown into the atmosphere by one volcanic eruption. All in all, only about 400 or 500 volcanoes on Earth are considered active or dormant. I guess he means, okay, against a multiplicity of extinct cones. So dormant means it's not extinct. It just hasn't gone off in a while.
Yeah.
Yet only 500 or 600 years ago, many of the presently inactive volcanoes were still active. This points to a very great activity at a time only a few thousand years ago. At the rate of extinction witnessed by modern man, the greater part of the still active volcanoes will become inactive in a matter of several centuries. And Randall has talked about this too, how there's this strange, you can see this like steep slope of leveling off of volcanic activity throughout history, implying that there was something happened in the not too distant past that caused a whole bunch of volcanic activity to go down, and we're still ramping down from that.
Yeah. So that's back to what, there's all the heat that you need.
Yeah, to make
like
ice
all
age.
these volcanoes are just going off and making plenty of heat.
Okay, the Watcher says a dormant volcano is an active volcano that is not erupting but supposed to erupt again. An extinct volcano has not had an eruption for at least 10,000 years and is not expected to erupt again in a comparable or comparable timescale of the future.
So I wonder if if you could say that like global volcanic activity, like heightened volcanic activity can cause ice ages. Right? If you just postulate that could cause ice ages, and you look back and you see we have, stades and interstades of these ice ages. The low volcanic activity is the interstade, where there's just not enough heat to pick up all that water vapor
and put it, and drop it as ice.
So then, what's the mechanism driving the volcanism?
Right. Yep. Good point.
Could it be? Could there be a terrestrial mechanism that's cyclical?
Some internal cyclical mechanism.
Yeah, that doesn't seem likely for some reason.
Right. Doesn't seem likely.
But I don't know. What do I know?
Yeah, we don't know anything. We say this all the time. We know nothing. Another great question from the Watcher. He says Mount St. Helens was considered extinct, and then it blew up in the 80s.
Yeah.
So, do they, do they factor that in?
I wonder if is there just a timeline? Like, if so many thousand years, you can say it hasn't done anything, so it's extinct.
Yeah, that's what he said. If it doesn't appear to have had an eruption in 10,000 years and is not expected to erupt again, they call it extinct. So Mount St. Helens was considered extinct because they had looked at the stuff around it and said, well, this is old stuff. It hasn't erupted in at least 10,000 years. Right, and then all of a sudden it starts rumbling. There's little earthquakes everywhere, and then boom, it freaking explodes.
Yeah. Wow.
Okay. Seas of lava and crater formations cover the entire face of the moon. Quote, no one who has observed the moon, even through a relatively small telescope, can forget this picture of tremendous catastrophe. a flood of molten lava that has engulfed and obliterated craters and mountain ridges in its path, unquote. Whether the crater formations on the moon, some of which reach 150 miles in diameter, result from bombardment by enormous meteorites or are extinct volcanoes, or, as I assumed in Worlds in Collision, are the congealed effects of bubbling activity on the surface of the moon that became molten, the face of the moon is indisputable proof of catastrophic events on a planetary scale. The theory of uniformity can be taught only on moonless nights. Bam! I love that quote. Which I did say on the podcast with Soraya, too.
I knew I'd heard that somewhere.
Yeah.
Eventually.
The theory of Alexis Perry, regularly quoted in textbooks, connects the occurrence of earthquakes in our time with the position of the nearest celestial body, the moon. Earth tremors occur more often when the moon is full or when the Earth is between the sun and the moon, when the moon is new or when it is between the sun and the Earth, and when the moon crosses the meridian of the afflicted locality, and when the moon is closest to the Earth on its orbit. So all four of those correlate to earthquake activity. He says, with the possible exception of the fourth case, the statistics for the last century appear to support Perry's theory. But if this statistical theory is correct, then we have to look to the celestial sphere for the stresses that are relieved in earthquakes. And the farther in time from the stresses, the less numerous and less violent are the shocks. So what he's saying there is if earthquakes can be correlated to the moon, right? Well, the moon is just kind of tugging on the Earth all the time, and there are times where it tugs in such a way where it allows a stress that's been built up to be relieved, because that's what an earthquake is.
Yeah.
Then he's saying, well, if we have to look to the celestial sphere to relieve those stresses, then we must also look to the celestial sphere to cause them. Mm-hmm. That's what he's talking about.
That's a good point.
Finally, a third natural phenomenon shows a definite downward curve. The number of comets visible to the unaided eye in recent centuries is only a small fraction of the number of cometary bodies that were observed in the historical past, in comparable periods of time. Whereas in our age, about 3 comets are seen without the help of a telescope in the northern hemisphere in a century, in the days of Imperial Rome 19 centuries ago, comets were so frequent that they were associated with many state events, such as the beginning of the rule of an emperor, his wars, and his death. Often, more than one comet was seen simultaneously. Some of the comets were spectacular and glowed even in the daytime. Approaching the sun, a comet emits a tail consisting of gases and dust particles. It is believed that these tails are wasted and that their material does not return to the nucleus. A comet that recurs every 76 years, as Halley's Comet does, would have to grow and lose its tail about 40 million times if we take the usual figure for the age of the solar system, and such a wasting would have long ago reduced this comet to nothing. I think he's pointing out that it must be a young object, relatively speaking. It can't every 75 years come in and lose a whole bunch of material and be millions and millions and millions of years old.
Yeah.
Right? So what's the watcher saying here? Theorized the explosion of the Yellowstone volcano that created the Yellowstone caldera roughly 630,000 years ago created an 80-year winter, but not an ice age. Yeah, so the Yellowstone wasn't in the right place to dump lava into water. Right?
Good point. Yeah.
Okay. Okay, chapter 10.
It's really interesting, too, that the seeing all these comets in the sky portends destruction in the future, like far in the future.
Yeah.
And you don't really know when.
Yeah. Yep. That does seem to be. And it's weird because the comets that we're familiar with in present day and age are harmless, you know? So I've seen this correlation people are making, like, why would ancient cultures think comets portended doom when they're just beautiful things in the sky? You know, unless there's some cultural memory of you see a beautiful thing in the sky and it keeps getting bigger and bigger and bigger and brighter and bigger, and then there is catastrophe.
Yeah, like if it's captured by the sun and it's making regular revolutions, and it keeps getting closer
and closer, yeah.
and closer.
And one day it's taking up the whole sky,
God.
And it's just like you got this bright head over here and this tail going all the way across the hemisphere. And then it impacts, or parts of it impact somewhere. And then next thing you know, you have thunderstorms and crazy lightning and mud rain and acid and volcanoes going off and earthquakes everywhere and huge tidal waves rolling in. Yes, you would learn to associate those things in the sky with death and destruction.
That's crazy.
Yeah.
And now we see that. Who was showing us that image of the dust that went up in?
That was Dr.
point?
Martin Sweatman.
That's right.
The zodiacal dust.
Yes.
Yeah. Zodiacal light. Yeah.
I've been watching it. Not watching. I've been listening to his videos on the Younger Dryas impact hypothesis and the papers.
Yeah.
All the papers in the bibliography, and it's awesome. It's really good.
Yeah. We need to get him back on here to talk about it. Okay, so H.E. Suss, that's S-U-E-S-S, I'm guessing that's pronounced Suss, of the United States Geological Survey reported recently that wood found at the base of interbedded blue till, peat, and outwash of drift, and ascribed by its finder to the late Wisconsin or last glaciation, is, according to radiocarbon analysis, but 3,300 years old. With a margin of error up to 200 years both ways, or of the middle of the second millennium before the present era. Still more recently, Suss and Rubin reported that, quote, a glacial advance in the mountains of western United States was determined to have occurred about 3,000 years ago, unquote. Already there is an accumulation of similar results that do not fit into the accepted scheme, even if the ice age is brought as close to our time as 10,000 years, which it roughly has been now.
Yeah.
It's interesting as I'm going through this book, I'm seeing that he's pulling out stuff like, to me, looks like, okay, this is pointing to the Younger Dryas anomaly. They haven't recognized it as that yet, though, I think, in this time. So, okay, he says, Professor Johnson says, quote, there is no way at the moment to prove whether the valid dates, the invalid ones, or the present ideas are in error, unquote. He says also, quote, until the number of measurements can be increased to a point permitting some explanation of contradictions with other apparently trustworthy data, it is necessary to continue to form judgments concerning validity by a combination of all available information, unquote, which is a really roundabout way of saying we're throwing out these dates that we don't like. I'm serious. That's what he's saying. Okay, Libby recognizes that the exactness of this method, his method, is dependent on two assumptions. The first is that for the last 20 or 30,000 years, okay, so let me figure out who Libby is because I skipped some stuff here. All right, Libby is the guy who came up with radiocarbon dating, I'm pretty sure. Yes. In 1947, an ingenious new method of investigating the age of organic remains was developed by W.F. Libby of the University of Chicago. So that's who we're talking about here.
Okay.
All right. Sorry about that. So Libby recognizes that the exactness of his method is dependent on two assumptions. I thought this is so important. The first is that for the last 20 or 30,000 years, the amount of cosmic radiation reaching our atmosphere remained constant.
Right.
I've been saying this. The other, and this is something I didn't think of, the other is that the quantity of water in the oceans has not changed in the same period of time.
Oh, my God. Why is that?
Actually, only a minor part of the radiocarbon created by cosmic rays is absorbed by plants and animals, the so-called biosphere. A still smaller part is present in the atmosphere, but the largest share of radiocarbon, or C14, is absorbed by oceans. So the smaller the oceans, the less they will absorb, and the more C14 you end up with in
that
the
would
stuff.
put the Younger Dryas closer to us than 12,000 years ago.
This is why radiocarbon dates have had to be calibrated when they date them to 10,000 years.
Well, yeah, because now they have dendrochronology all the way back to 12,000 years ago.
Right. So we know that the oceans were 400 feet lower. So the oceans were absorbing less C14, so more C14 was in the atmosphere and thus ends up in the plants and the animals, which means that you get younger dates when you're dating stuff from that period. And as the sea level rises...
you get younger dates.
Yeah, because it has more. Since the oceans are lower, they absorb less of it.
Yeah. Okay, gotcha.
So you end up with more in the animals, in the organic stuff.
And we're looking at the decay rate, so
right.
The more they have, the younger it is.
Right.
Yeah. Okay. Got it, gents.
So Libby stressed the significance of these factors. It transpires that if there were cosmic catastrophes in the past, cosmic radiation could have reached the Earth at different intensities. And then, so in a future book, I intend to show that the waters of the oceans and their salts were increased substantially in a recent geological age. Bearing in mind these limitations, I confidently expect that in the field of geology, more and more puzzling results of radiocarbon tests will compel a full-scale revision of the dating of glacial periods.
Yeah, so just going back to the dating, since we have the dendrochronology that actually goes back that far, we know how to calibrate carbon-14. So you can get a sample of something organic, and then you can date it with carbon-14 dating, calibrate it using the dendrochronology.
Yes, that's right.
So that's pretty cool. We can then therefore assume that our dating for this, however long the dendrochronology goes, and then plus, we've got now ice cores and stuff that we can count the years.
Yep.
That stuff's pretty accurate.
Yeah. It's gotten pretty accurate. It seems like it should be pretty accurate.
Yeah,
right?
I mean, give or take 100 years, just
right.
Throw 100 years out there. I mean,
right. I think the dating now is pretty, because they have multiple vectors, like you said, that they're able to point to, and now they see that the radiocarbon dating has
this is not, the dendrochronology is based on the assumption that the tree rings are made every year, which we can actually observe happen.
Yeah.
So assuming that...
The only problem is that you have one tree that lived for 500 years through a certain period, and then another tree that lived for 300 years, and they have an overlap, and you have to match that overlap.
Right.
And that's where it kind of gets, because then it's visual. I mean, it's visual. That's what it is. You're like, okay, here's a string of 8 rings, and they have this particular pattern. Can I find something that looks kind of like that pattern in this other tree? And you're just like, I mean, have you ever tried to do that?
No. But there could be more things than just visual stuff. Like they're, depending on, I don't know what they test with, but
yeah, you're right.
They could know, temperatures of the winter and stuff like that based on, the tightness of the grain or so. I don't know.
Yeah,
you never know.
Yeah.
Right. There could be other.
There might be oxygen isotopes caught in there. I mean, yes,
and that is something that is also in the ice cores. Right. So
yes.
You can see all that. So I don't know, but I'm just saying there could be more than just like looking at it.
No, they're just looking at it. It's like they did with the lake varves. Like they thought that this was a great thing back in the day. They were doing this with varves in lakes. And they did the same thing where they would like basically do visual comparisons and say, okay, these layers in this lake down here match these layers in this lake up here, and they would put together this whole chronology of melting glaciers.
Well, I think
it just turned out to be very arbitrary because it was a visual comparison.
But imagine, let's say in the 500 years that this one tree lived, there was a volcanic eruption. Right, that might make a very distinct ring.
Yeah.
That year, or maybe for a couple of years.
Yeah,
and that would just be unlike any other rings in the tree. And then you can find another tree that also has the same number of distinct rings that have the same characteristics of distinctness. And that could be a pretty good, thing where you're like, okay. And then if you line those two up, it's like, wow, they look the same too, buddy.
Yeah, exactly. Yeah. Yep. I'm not doubting the dendrochronology. I think they've done good work there. I'm just pointing out that it's not necessarily settled science.
Yeah, I'm not saying it is. I'm saying we can.
I'm pretty confident in the dates going back to the Younger Dryas, though.
That's what I meant. Yeah, basically.
I mean, it's not. Why are we questioning that?
My point was comparing it to the assumption of the what's the word constant of
influx of cosmic rays. Yeah. So now we know, because of the other proxies like dendrochronology and varves and ice core stuff that they have been using to compare to the C14 dating, that there's something wrong with the influx of cosmic rays, and it happened around the Younger Dryas period because there's a sudden jump. Based on the dating, there's this sudden jump that doesn't even out until almost 2,000 or 3,000 years later.
So the flipping poles, people could be flipping right about it.
Yeah,
the poles went down, the magnetic field went down.
Yep.
We got nailed.
Yep. I mean, there might have been massive solar activity that caused it to, okay, so Watcher's putting up other good stuff here. He says, Willard Frank Libby was a physical chemist. His theory is based on C14 forming radioactive CO2 that is taken up by plants and then eaten by herbivores and then carnivores. That's right. And, okay, so he's asking a question that wouldn't you have larger amounts of it at the top of the food chain? I don't think so, Watcher. Maybe. I haven't looked at that, but, most of the C14 is actually absorbed by the very small stuff. And then that stuff ends up in larger animals because of what they're eating. But plants are directly consuming it. So you would think that they would have the most, I guess. I don't know. The idea is that it ends up sort of spread out evenly because it's spread out evenly everywhere else. Okay. The glacial lake Agassiz.
Aziz!
Lake Agassiz, the largest glacial lake of North America, once covered the region at present occupied by Lake Winnipeg, Lake Manitoba, a number of other lakes in Canada, and parts of the north central states and of the United States. It exceeded the aggregate area of the 5 Great Lakes tributary to the St. Lawrence. It was formed when the ice of North America melted. Study of its sediment, however, disclosed that its entire duration had been definitely less than 1,000 years. A measure of time unexpectedly short. This indicates also that the glacial cover melted under catastrophic conditions. So again, I think we're talking about the Younger Dryas here. They just haven't labeled it as that yet.
Yeah.
Warren Upham, the American glaciologist, wrote, quote, "The geologic suddenness of the final melting of the ice sheet, proved by the brevity of existence of its attendant glacial lakes, presents scarcely less difficulty for explanation of its causes and climatic conditions than the earlier changes from mild and warm pre-glacial conditions to prolonged cold and ice accumulation." Again, we're talking here, they're puzzling over the Younger Dryas. You had a relatively slow, sort of gradual, the Balling Alarad meltdown of all the ice, starting from the last glacial maximum up to the beginning of the Younger Dryas, and then there's a sudden catastrophic melting, followed by a catastrophic freezing and buildup of ice that extended almost as far down as the LGM, the late glacial maximum, before it was finally melted for good at the end of the Younger Dryas. So that's what they're having problems with here. Okay, Niagara Falls. When Charles Lyell, on his trip to the United States, visited Niagara, he talked with someone who lived in the vicinity, and he was told that the falls retreat about 3 feet a year. Since the natives of a country are likely to exaggerate, Lyell announced that 1 foot per annum would be a better figure. God, this is really annoying. From this, he concluded that over 35,000 years were necessary from the time that the land was freed from the ice cover and the falls started their work of erosion to cut the gorge from Queenston to the place it occupied in the year of Lyell's visit. Since then, this figure has often been mentioned in textbooks as the length of time from the end of the glacial period. Right, so somebody's
Wrong.
like, yeah, somebody's like, hey, it retreats 3 feet a year, and he's like, well, locals always exaggerate. It's probably 1 foot. It's just,
Yeah.
It's arrogance there, I guess. Okay, the Rhone Glacier.
He was exaggerating.
Yeah. The lifetime of a glacier is determined by measuring the detritus deposited by the melting ice. Albert Heim, the Swiss naturalist, estimated the age of the glacial river Muota that flows into Lake Lucerne as 16,000 years. F.A. Forel, another Swiss naturalist, undertook an evaluation of the detrital mud deposited by the Rhone Glacier on the bottom of Lake Geneva. He arrived at a figure close to 12,000 years as the span of time necessary for the mud and detritus to have been deposited on the bottom of the lake, or from the height of the Ice Age to the present. Forel's result actually signifies that the Rhone Glacier, which feeds the river and the lake, is evidence of the short duration of the post-glacial period, or even of the entire Ice Age if the origin of the lake goes back to the first glacial period. These estimates, when announced, were much lower than expected. The eminent French geologist of the beginning of this century, and a colleague of Heim and Forel, A. Cochon, I don't know how to say it, Cochon de la Parent, arrived at even more radical results. In the time of the greatest expansion, the Rhone Glacier reached from Valais to Lyons, De La Parent took the average figure of progression as seen today on larger glaciers. Mer de Glace, a glacier on Mont Blanc, moves 50 centimeters in 24 hours. Wow. That's pretty fast.
Yeah.
50 centimeters a day. Moving at a comparative velocity, the Rhone Glacier, when expanding, would have required 2,475 years to progress from Valais to Lyons. Then, comparing the terminal moraine, or stone and detritus accumulation of several present-day glaciers with the moraines left by the Rhone Glacier at its maximum expansion, De La Parent again arrived at a figure of about 2,400 years. He also concluded that the entire Ice Age was of very short duration, which he was right. If they're looking at the Younger Dryas, we're talking about 1,300 years, right?
Yep.
I think that's what's happening in a lot of this. To this, another geologist, Albert Pink, objected. His objection was based not on a disapproval of the above figures, but on a claim that great evolutionary changes took place during the consecutive interglacial periods. The divergence of opinion between them was so great that hundreds of thousands of years in Pink's scheme were reduced to mere thousands of years in De La Parent's calculations. Pink estimated the duration of the Ice Age with its 4 glacial and 3 interglacial periods as 1 million years long. Each of the 4 glaciations and deglaciations must have consumed 100,000 years and more. The argument for his estimate is this: how much time was necessary to produce the changes in nature if no catastrophes intervened? And how long would it take to produce changes in animals by means of a process that in our own day is so slow as to be almost imperceptible? So we've pointed this out on the show many times that often the amount of time that they give these periods is because of how much they think evolution needs to work.
Right.
So even though the geological evidence points to very short periods, they're like, no, because we see all these changes in the animal species and evolution takes a long time. So it must have been millions of years.
Yeah. So what does that do? What does that do to the model of evolution? Is it all these catastrophes that cause this rapid evolving of species?
I don't think that it destroys evolution. I think that it drastically changes what's actually happening, in my opinion. Right?
Yeah.
That it's, like, what does Randall call it? Punctuated equilibrium or something? Like, we have these long periods of uniformitarian stuff and then drastic changes that all happen very quickly, both in geologically speaking and evolutionarily speaking. Right?
Yeah, that's crazy.
Now that brings into question, what are the evolutionary processes? Because now we're not looking at survival of the fittest or the non-survival of the least fit, but more like what Birch says, how to explain the arrival of the fittest in the first place.
Yeah.
I thought that was a great comment,
I wonder if it all has to do with the recessive genes, all these genes that we don't even, the DNA, we're like, well, 90% of this stuff is just junk, right? Junk DNA.
Yeah.
Maybe that's all there
Yeah.
for those types of circumstances.
Right. And something turns them on and then things start getting rearranged. And next thing you know, you have species filling up ecological niches that had been emptied by a catastrophic period.
Right.
I mean, to me, that's really cool.
Yeah. That is cool. And we're almost up break time.
Oh, yeah.
Actually, we're pretty much at break time.
So I'll read this little last piece here, the last bit of this. So the recent fieldwork in the Alps actually revealed that numerous glaciers there are no older than 4,000 years. This startling discovery made the following statement necessary. Quote, a large number of the present glaciers in the Alps are not survivors of the last glacial maximum, as was formerly universally believed, but are glaciers newly created within roughly the last 4,000 years, unquote. And now that makes sense. I know we got to take a break. I'm just going to say that makes sense because we know that there was a climatic optimum after the end of the Younger Dryas where everything was much warmer than now, and sea levels were actually 20 feet higher because we had less ice cover. Now? Yeah. So, all right. Let's take a break.
Yep.
Snakes! Flawless.
Everything's going to be fine, folks. Just kick back and relax. Everything's gradually going to be destroyed. It will not happen catastrophically. Don't worry.
Everything will be destroyed, but very slowly.
That's right. And welcome back for the final segment of the final hour of the second half of the second day of the show.
Of episode 137.
That's right.
Which is
the fine structure constant.
That's right. A number that we don't understand.
Yeah. Physicists have this number on their walls and they worry about it.
That's right. So says Feynman.
We don't know why. So yeah, talking about this, we were during the break talking about this idea of gradualism, and you were pointing out that, what period of time are you talking about that we have to observe current processes?
Yeah.
Because current is actually not a period of time.
Right. It's not scientific.
So it's like,
when you say modern processes, you're like, okay.
If I learned about the uniformitarian model in the morning at 5 a.m., and then I started to watch the temperature rise as the sun was coming up, I might flip out because it's going up like 3 or 4 degrees every 30 minutes.
Yeah. Yeah.
And they're like, this is going to continue happening forever. And we're all going to die.
Yeah. So what is the arbitrary length of time that you designate for meeting modern processes?
Yeah,
and why?
Averaging things out.
Yeah. Why do you just pick that arbitrary time when you talk about modern processes? And you pointed out that like weather. So if your arbitrary time span was 10 minutes long and you're in the middle of a thunderstorm, what does that mean?
And you're looking at the river and you're like, wow.
Yeah.
Okay, that's the normal rate.
Right. Yeah.
And it's tearing up a lot of trees and rocks and stuff.
Yeah. And I tried to point out in a previous show, I was comparing it to like, a catastrophic injury that a person might have or any animal. If you look at any arbitrary length of time in their modern normal life, there's nothing to explain all the injuries they get in less than a second.
Right.
And you can't use any of those processes that you would see through 99.9999% of their life to explain those injuries.
Yeah.
And that's why uniformitarian is crap. It's just crap. You can't say that. It's an arbitrary thing. So, yeah. I want to use much stronger words, but,
Crap is a strong word. It is. It's a powerful
Cover your kids' ears, folks. I'm saying crap multiple times. Okay. The falls of St. Anthony on this stream at Minneapolis have excavated a long gorge by removing the bedrock. In the 1870s and 1880s, N.H. Winchell made this falls the subject of a study. Comparing topographical maps covering 200 years, he concluded that the falls had retreated 2.44 feet yearly. If this was the constant rate of retreat, the falls must have started 8,000 years ago. But here, too, a larger stream carrying abundant detritus, which abraded the bedrock, must have flowed when the ice cover melted. J.D. Donna, studying that area of Lake Champlain and of the northeastern states in general, came to the conclusion that prodigious floods of almost unimaginable magnitude accompanied the melting of the ice cover. In the lower part of the Connecticut River, the floods rose 200 feet above the present high water mark. And if this is true for those regions, it must be true also for the valley of the Mississippi. Consequently, the gorge of the Falls of St. Anthony must be of a more recent date than Winchell calculated, even though his figure was widely regarded as much too low. So we were talking about this in the break, too, that, the idea of Niagara retreating 1 feet or 3 feet a year, actually, because it starts at the melting, and that was catastrophic, the rate then would have been enormous, and then it slowly drops down over time.
And it may have gone through multiple pulses.
Yes.
Due to various different cataclysms or big floods and stuff.
Right.
But that's where the whole discussion started. Because like, well, if you average it out, it's probably 3 feet a year, which is roughly, 12,000 years.
Right. Puts it at 12,000 years when it started to do that erosion, which is about right.
Yeah.
Okay. Lake dwellings. At the close of the Stone Age in Europe, But about 1800 BC, lake dwellings existed in which man and his cattle lived, protected from wild animals. The structures were erected on wooden poles driven into the ground. Remains of such dwellings were discovered on the shores of the lakes of Scandinavia, Germany, Switzerland, and northern Italy. Sometime in the middle of the second millennium before the present era, a, quote, high water catastrophe, unquote, occurred. The villages were overwhelmed and covered with mud, sand, and calcareous deposit. Calcareous. Life came to an end in all lake dwellings. Then for about 3 or 4 centuries, they were not rebuilt, but after 1200 BC, new villages were erected, in some places directly on top of the earlier ones, in other places on new ground. And this was in the Bronze Age in Europe. Bronze articles are found among the remains of the lake dwellings of that period. After a second period of prosperity, which lasted about 4 centuries, in the 8th century before the present era, a new catastrophe overwhelmed the lake villages on all the lakes of Central and Northern Europe, and again, it was a high water catastrophe. Once more, mud and sand covered the villages on poles, and, abandoned by man, they were never rebuilt. So 2 times in a short period, people are like making these big cities out in lakes. They, drive poles into the sediment of the lake, and then you build all these walkways and houses out there, and you're protected. And then the lake suddenly rises 200 feet or whatever, and then drowns everything, covers it in mud. A couple hundred years later, they come and try it again, and after 400 years, completely destroyed. And all this is preserved because the cities are actually buried in the silt. Yeah.
I remember hearing about the Greenland ice cap melting. Yeah. And they're finding villages and stuff under this.
Yeah. You know what I mean? Old farming villages. They're farming down there. Yeah.
Yeah. But we're all going to die because they're melting. No, there's just revealing more farmland.
Right. H. Gams and R. Nordhagen made an extensive survey of German and Swiss lakes and fens. You know what a fen is?
No.
I think it must be like a type of lake, I guess. I'm not sure. Watcher, can you look up fen? F-E-N? And published a classical work on the subject. They found not only that the lakes at 2 periods in the past, the end of the Neolithic age in Europe, in the middle of the 2nd millennium BC, and in the 8th century BC, they were subjected to high water catastrophes, but also that these catastrophes were accompanied or caused by very strong tectonic movements. The lakes suddenly lost their horizontal position, one end often being tilted up, the other down. Okay, so the Watcher says a fen is a low and marshy or frequently flooded area of land, like wetlands. Okay, so the lakes suddenly lost their horizontal positions, one end often being tilted up and the other tilted down, so that the old strand line may now be seen to run obliquely to the horizon. Such is the case of Ammersee and Wormsee in the foothills of the Bavarian Alps and of other lakes on the alpine fringes. In these catastrophes, the water of the Bodensee, which is Lake Constance, rose 30 feet and the bed was tilted. The tilted strand lines of lakes were also found in regions far away from the Alps, for instance in Norway by Berweis and Hansen, and in Sweden by De Geer and Sandergren, dating from the same ages. So all around the Alps, lakes were suddenly flooded and their strand lines were tilted, and it's remained that way. So there was something seismic happening at the same time.
Or it's isostatic.
Yes, except that these were fast. So
but I mean, if there was
could happen fast. Yeah, you're right.
If there was rapid melting or something, it could lift up
But this, again, we're talking about 2000 BC. This is the dating for this. So like rapid isostasy would be interesting at that period. All of the explored lakes of the Swiss Alps region, as well as of the Tyrol, the Bavarian Alps, and around the Jura, were flooded twice in catastrophic surges of water. And he gives this Hochwasserkatastrophen is the word that he uses right there. Well, that's one word, Hochwasserkatastrophen.
That's German or Dutch?
I guess, yeah.
Hochwasserkatastrophen.
Hochwasserkatastrophen. And the cause lay in tectonic movements and in the sudden melting of glaciers. It happened in the post-glacial period, the last time actually in the historical age, not long before the Romans started to spread into those same parts of the world. Gams and Nordhagen also presented extensive material to show that the tectonic disturbances were accompanied not only by high water catastrophes, but also by climatic changes. They undertook a close examination of the pollen content of peat bogs. Since the pollen of each species of tree is characteristic, it is possible to detect by analysis what kinds of forests grew in various periods of the past, and consequently the then prevailing climate. The pollen disclosed a, quote, radical change of life conditions, not a slow building of fens, unquote. Men and animals suddenly disappear from the scene, although at that time the area was rather thickly populated. Oak was replaced by fir, and the firs descended from the heights on which they had normally grown, leaving those heights barren. Dropping ocean levels.
That's really cool.
Yeah.
I like that.
Yeah, that they can figure out what was growing nearby the peat bogs because of the pollen that's caught in the layers.
That's awesome.
Yeah. In many places of the world, the seacoast shows either submerged or raised beaches. The previous surf line is seen on the rock of raised beaches, whereas when the coast became submerged, the earlier waterline is found chiseled by the surf in the rock below the present level of the sea. Some beaches were raised to a height of many hundreds of feet, as in the case of the Pacific coast of Chile, where Charles Darwin observed that the beach must have risen 1,300 feet only recently, quote, within the period during which upraised shells have remained undecayed on the surface, unquote. So however long it takes shells to decay on the surface, 1,300 feet above the present sea level, there's shells up there and they're not decayed yet. So, I mean, the shells go away pretty quick, don't
Really?
they? Or maybe, I guess, if they're being worn by water. Because, you see them on the beach, and you can find the ones that are just, like, worn down to nothing. But I guess that's constant wave action that does that, maybe.
Yeah, I just don't know.
Yeah.
I know the shells we find, like the little snails and stuff that we find in the Indian middens around here, you can just crush them.
Right.
And then I have found some more recent ones that you can still see some color on, and they're harder.
Ah, okay.
But there's some that you get that
They're paper thin.
Yeah, they're just really old, completely bleached, and then they just crush in your hand.
Yeah, I'll have to look that up. I wonder.
I don't know.
Yeah. And I mean, just Chile, so
I guess it has to do with the taphonomic
circumstances.
situation.
Yes.
Yeah, the circumstances, because there are layers of sediment here that have oyster shells, and they're still
shell.
They're still shell.
Yeah, they're still mother of pearl.
Yeah, some of them are very hard. I mean, maybe they've been replaced by
fossilized,
minerals. Well, they all, We learned that fossilization does not mean turn to stone.
Yeah.
It's so you can find a bone that's been buried in sediment, and it's still bone, but it is considered a fossil.
Right.
Because it has been
preserved.
It's in some way preserved in the layers. I don't know. Let me just
find this out.
Let's see what this old dictionary says.
Well, I can keep going here on the...
Yeah.
Okay, so he says, Darwin thought that also that the most probable explanation for this 1,300 feet, seemingly 1,300 foot rise of the beach in Chile, the most probable explanation would be that the coast level with whole and perfectly preserved shells was, quote, at one blow uplifted above the future reach of the sea, unquote, following an earthquake. In the Hawaiian Islands, there is a 1,200-foot raised beach. On Espiritu Santo Island in the Hebrides in the southern Pacific, corals are found 1,200 feet above sea level. Corals do not grow high above the sea or in the depths of the sea. Their formation is limited to levels close to the surface. Thus, corals of bygone ages are recorders of previous sea levels. In numerous instances, evidences of submergence and emergence are seen on the same stone. One such case we have discussed, the Rock of Gibraltar. To a lesser degree, the phenomenon is repeated in Bermuda. From the evidence of submerged caves, the sea level at Bermuda must, quote, at one time have stood at least 60 to 100 feet lower than at present, unquote. While from raised beaches, quote, it appears to have stood at one time at least 25 feet higher than at present, unquote. Yeah, so I think what we're looking at there is Younger Dryas level period and then climatic optimum period after the Younger Dryas, because 25 or 30 feet above what we have now is what they had, around 8,000 BC or something like that. And then, hundreds of feet lower than what we have now is what you had during the Younger Dryas. So... What'd you find?
Okay, so in the Dictionary of Geological Terms, 3rd edition, and the copyright 84, I think, 1984 is the latest. Fossil. Any remains, trace, or imprint of a plant or animal that has been preserved in the Earth's crust since some past geologic or prehistoric time. Loosely, any evidence of past life.
Okay.
So it says nothing about it being, mineralized or turned
Right.
to stone in any way.
It just has to be not from the present geological age. So if it's in the Holocene, maybe it's not considered a fossil. Maybe. That's what I'm wondering.
Since some past geologic or prehistoric time.
Okay. So prehistory is less, yeah.
Said of any object that existed in the geologic past and of which there is still evidence. An example, fossil waterfall. Applied to coal, oil, and natural gas, i.e. fossil fuels. Loosely applied to persons or equipment involved with the fossil fuels. Fossil engineer. Anyway. So, yeah, I mean, if based on this definition, I would assume if we find a bone of a bison in an Indian midden, it's a fossil.
But if I go out in the woods and I find a deer skull, is that
That's
a fossil?
not a fossil.
No,
Yeah,
because it's just on the surface. It
Yeah, I mean, it would
has to be buried in sediment.
Well, because it could have been uncovered,
Yeah.
right, by a flood or something. So prehistory. So maybe if you find a Roman skeleton or something, that's not a fossil.
No.
That's not prehistory, is it? Prehistory is like 6,000 years.
Before writing, maybe? Yeah, I don't know.
Isn't prehistory considered before? Well, I guess now it would be Göbekli Tepe.
Yeah. Prehistory is generally, they're talking about before the advent of writing, of written history.
the written
So
records.
6,000 BC, previous to that. But I mean,
This is ridiculous.
Yeah, I know. That's what I'm saying. These terms are to say using are not accurate. Prehistory is kind of a vague.
I would not call a bison bone I found in an Indian midden a fossil.
Right. But maybe it is considered one. I don't know.
Yeah.
It's a good question.
I've never considered anything that was not turned to stone a fossil.
Yeah.
But I've recently found out.
or imprinted on stone or in some way interacting with stone. Like, right, we find those shadow fossils or whatever.
Right. Yeah, that's a fossil. It's
Yeah.
an imprint.
Yes.
It's this definition says that. Any
Right.
remains or imprint. Specifically of something that was life.
Yeah. But we associate it with stone. Like if I find a
Right.
footprint in dirt, that's not a fossil.
Right, but in many cases, these mammoths that they're excavating that were
Yeah,
that died off,
still have flesh on them.
that are buried in sediment or whatever.
Yeah.
their bones are still bone.
Yeah.
They're
still
called
considered
fossils.
Yeah. And that's because they're definitely from a previous geological age. You know
Right.
what I mean?
Yeah,
You
yeah.
don't even have to say prehistory on those guys. They are from the Pleistocene.
Right, I agree with that.
Yeah.
Yeah, so we'll just go with that. If it's from the Pleistocene or before, we'll call it a fossil.
Okay, yeah. All right.
Done deal. I'm like, I bought that book. Randall and Brad were just like waving their books, bragging. Oh yeah, you got to get a book. So I get a book because Randall's always nailing me with like, well, instead of sitting there twiddling your thumbs, Kyle, why don't you get engaged and look up this
Kyle.
yeah. So look up this term. So I go, looking it up on my phone, and then the YouTube guys are like, get a computer.
Yeah.
I'm like, I have a computer.
That's right.
Anyway.
It's this big computer in front of us. What do you think we're using to record the show?
So I buy this book. I'm like, yeah, I need this book.
Yeah. It's a great
And
book.
then every time the term comes up, I go to look it up, and it's not in there because it's from 1984. And all this stuff we're talking about is like
Yeah.
more recent stuff. Like I looked up Fen. Nope.
No.
The fossils in there, so that's
Yeah.
good. I love the book though.
It is a good book. I think Finn is not necessarily a geological term.
Yeah, I know. I try.
Yeah.
But it is a great book because there's a lot of stuff in here that otherwise it just makes it easier to look up when I
Yeah.
wouldn't even know what to look for or what to search for on Google.
Yeah.
So
Google it.
good book. Sorry. Continue.
All right.
Get engaged, Russ.
In numerous instances, Okay, I already did that. Okay, so the 60 to 100 feet lower at present, while some raised beaches it appears to have stood at one time at 25 feet higher than present in the Bermudas. These changes date from different ages, but common to all of them is the absence of intermediate surf lines. Right? So you have a surf line at 25 feet above now, and there's just no intermediate surf line and between that one and so it seems to be a fast change.
Seems to be catastrophic.
Yeah. If the emergence or submergence had been gradual, intermediate surf lines would be seen in the rock. And there are places in Canada where isostasy is still occurring, and you could see all of these like strand lines going up. So there are intermediate places in some places. R.A. Daly observed that in a great many places all around the world, there is a uniform emergence of the shoreline of 18 to 20 feet. In the Southwest Pacific, on the islands of Tutuila, Tau, and Ofu, and on Rose Atoll, all belonging to the Samoan group but spread over 200 miles, the same emergence is evident. In Daly's opinion, this uniformity indicates that the rise was due to, quote, something else than crustal warping, unquote. A force pushing from inside would not be, quote, so uniform throughout a stretch 200 miles long, unquote. Nearly halfway around the world at St. Helena in the South Atlantic, the lava is punctuated by dry sea caves, the floors of which are covered with water-worn pebbles, now dusty because untouched by the surf. The emergence here is also about 20 feet. At the Cape of Good Hope, caves and benches also prove recent and sensibly uniform emergence to the extent of about 20 feet. So this is I think, again, we're looking at the climatic optimum when we had much less ice cover and the sea levels were generally 20 feet higher than they are today.
Man.
Daly proceeds, quote, marine terraces indicating similar emergence are found along the Atlantic coast from New York to the Gulf of Mexico, for at least 1,000 miles along the coast of eastern Australia, along the coasts of Brazil, southwest Africa, and many islands of the Pacific, Atlantic, and Indian Oceans. In all these and other published cases, the emergence is recent, as well as of the same order of magnitude. Judging from the condition of benches, terraces, and caves, the emergence seems to have been simultaneous on every shore, unquote. Of special interest is the time of this change. According to Daly, quote, this increase of the ice cap or caps has been tentatively referred to late Neolithic time, about 3,500 years ago. At that approximate date, there was some chilling of the northern hemisphere at least, followed by a prolonged period when the world climate was distinctly warmer than now. Late Neolithic man lived in Europe 3,500 years back, unquote. As to the date of the sudden drop of oceanic levels, Cunin writes, quote, the time of the movement was estimated by Daly to be probably some 3,000 to 4,000 years ago. Detailed field work in the Netherlands and in eastern England has shown a recent eustatic depression of the same order of magnitude as deduced by Daly. Here the time can be fixed as roughly 3,000 to 3,500 years ago, unquote. Thus, the work in the Netherlands and in England confirmed not only Daly's finding, but also his dating. The ocean level dropped, of course, all over the world. There was not a slow subsidence of the bottom, or a slow spread of the ocean over land, or a slow evaporation of oceanic water. Whatever it was sudden and therefore catastrophic. In many places all around England and Wales, there are submerged forests, which are dated as, quote, probably post-glacial or recent, unquote. On the other hand, their submergence did not take place within the past 2,500 years. Some of the submerged forests have these stumps of their trees rooted to the spot. The list of these forests is very long. Submerged forests were observed also in many other places. For instance, near Greenland and off the east coast of America. There exist also less reliable reports of walls of sunken cities spied underwater in the North Sea, off the Atlantic coast, in the Mediterranean, all around Europe, and also as far away places like off the Malabar coast of India. Only several thousand years ago, as the raised beaches and sunken forests evidence, the land rose and then fell and traded its domain with the sea. Oh, that was cool.
You remember that place we used to go when we were kids, Cape San Blas, Florida?
Yeah.
There's this cape, long cape, and it was I guess it was about 14 miles long.
and it was a state park.
Yeah, most of it was a
on
sanctuary, right?
Yeah, but there's one part of it that was, property owners, there's condos and stuff, and we used to go there. It had two ends, so I'm trying to think of what the shape was. I think of an upside down T, but cut one like the right side of the T off just to a short little stub. So you have the cape going off to the left is real long on that side of the T, and then on the right side, it's really a short little thing. It's like 1 mile.
Yeah, it's 1 mile, like a point that was 1 mile long.
So we used to go hike out to that 1 mile thing all the time, and like boogie board and whatever out in the
skimboard.
because the waves are coming from two different directions, and it's really badass. It was so cool.
You could catch a wave and then hit
another wave and jump
then
it,
ride
or
the middle.
Yeah, ride the middle, which is way faster. It was super cool.
Yeah,
and we used to go there every year for a month. And that part of the beach had all these trees out in the water. Like when you first got to that part of the Cape, like there was this area where there was just all these stumps going way out.
Yeah.
And if you walked out there, the whole bed was like this weird marshy sort of root black.
Yeah.
Kind of had a bunch of sand embedded in it.
Yep.
But it was mostly just roots and stuff of all these old trees. And it just occurred to me, like, why was that?
Yeah, why are those?
What's going on with those trees? Way out in the way. I never even thought about it. But
right, yeah. But clearly something has moved.
Exactly. Now, I guess that could have been that
the Cape itself is moving. The water is pushing the whole,
the Cape is shifting away.
Yeah. So the bay side is getting
but
smaller.
Still,
but it's
the
weird.
base of those trees was underwater.
Yeah.
And that's
Yeah.
weird. The base of the trees, if the land was the thing that was moving, the base of the trees the roots should have been sticking out instead of a trunk above the water. But it was just trunks of trees. These old, and I mean, who knows how old they were.
The roots were in place where the trees had grown, basically, is what it implied. Is the way that they were sitting out there. Yeah.
It was weird. Really cool place. Huge shells. And there wasn't a whole lot of people that went there back then.
Yeah.
This was in the early 90s.
Yep.
And there was just massive shells. We'd get up at 5 a.m. and go walk out to the end of that cape, and there's just all these crazy awesome shells everywhere.
Yeah.
I still have like a couple of these conch shells that are over a foot long.
Yeah.
That was so cool.
Enormous shells, yeah.
Anyway, I don't know. I was just thinking
there
about
is also a midden mound out there.
Of shells.
Yeah.
Yep. That was on the Cape on the other side, on the long end.
The long side, out in the sanctuary.
So, and it's huge. I mean, it's this massive mound that is 20 feet tall, probably, maybe more. I don't know.
It's enormous.
I've learned a lot about Midden since then, but I remember, the bay. It was on the bay side, and the very edge of it was being eroded away by the bay.
Yeah.
So there was about a 3 or 4 foot, sheer drop. Basically, the mound is smooth, and then it's basically just cut off 3 feet straight up, and the water's there, and then it goes down to the base of the water. But it's just all these little conch shells. I can't remember the name of those shells. I actually have one in the cube with us right now, but can't remember what the name was.
Yeah,
but
they
it's
were
just
bleached
full
white.
of those.
They were old.
Yes, just like the shells we find here in these mounds.
Yeah.
So maybe they were eating those little snails.
Maybe they were cultivating.
It's
them.
really cool.
Yeah. Yep. That was a very interesting place. I remember we went on walks one time. We walked miles trying to get to the other end.
Yeah.
That was an all day thing. It was a long walk.
It was 14 miles, I think.
Yeah.
Maybe it was round trip, 14 miles. I can't remember.
Something like that. But yeah, we had to go out there and see it.
Yeah, but if you guys...
There's no vehicles allowed, so the only way to get there was by boat or walk.
Yeah. If anybody lives in Florida, this was not on the Panhandle. This was on the Gulf side.
Gulf side.
I
don't know.
I don't know what it's called. It's not coming off the mainland.
Look it up on Google Earth, Cape San Blas.
Check it out.
Yeah.
It's a cool place. If you're nearby there, you should go camping.
Yeah. But
anyway,
the mosquitoes are awful.
Yeah,
so camping sucks.
Yeah, so should we wrap it up?
Yeah.
Speaking of Florida, well,
Yeah. We'll wrap it up. Because the next part is kind of we're changing subjects here. So next week we'll be doing the ruins of the East. We're going to be talking about more ruins and catastrophic destructions of the Caucasus and Cyprus and Egypt and Palestine and Syria. So,
right on.
cool stuff.
The Syria paper,
Yeah.
where forest fires create nanodiamonds.
Yeah, so we got a couple things to say before we end the show. First of all, everyone who's been supporting us, we thank you so much because we're actually to the point now where we're going to be able to use some of these funds that we've been getting to go on an actual expedition. So I'm not going to say too much about it right now, but we're going with George and Ben from Uncharted X and Chris from Dabbler's Den, and we're going to go check something out. It's going to be a lot of fun. And of course, we're Ben and us, we're bringing podcast equipment and lots of cameras. So we'll have all kinds of stuff to show you guys and talk to you guys about. And we'll probably do some podcasting on site. It's going to be a lot of fun. And we're able to do that because of all of your support. So thank you so much. And keep doing it, because when we have the money, we will go do stuff like this and we will report back to you on how weird it was. And, as long as we don't get lost and die, which is totally possible. So, I just wanted to say that. And
Yeah. So obviously, we totally appreciate all the support, no matter what the level is. It doesn't matter.
yeah.
But I wanted to give special thanks to these patrons, specifically Anne, Grimerica, Dennis, Brenner, Commander Frank, Garth, Janet, John, Kurt, Laser Printer Jam, Richard, and Scotty Baldwin.
Yes.
Thank you guys so much. And it's because of
you
because of
we're
that.
able to go on this awesome expedition, and we're really excited about this. So, thank you guys so much, and continue supporting us. Anything helps. Anything that builds the pyramid scheme, because we will be using the money to go do stuff like this and then report back to you guys.
Quote unquote, go straight to pyramids.
That's right.
That's what this is.
Yes.
That's
right.
what the phrase means.
Yeah. It means go look at weird ancient stuff.
Yes.
All right. Get my list here. So you guys can get a hold of us, brothersoftheserpent@gmail.com. And remember, when you send emails, I'm going to want to read them on the show. So tell me if you don't want me to read them on the show. And a lot of you have been catching that and doing it. So that's great. So right in the beginning, say, hey, don't read this on the show. And then I'll know immediately when I see it that that's not to be. Because if you put it at the end, it's possible that I'll read the whole thing on the show and then get to the end and be like, oh, shit. Whoops. Shouldn't have said that. So, remember that with the email.
And we're never gonna be on Disney, man.
No, I guess not. We're trying to get a Disney rating here. It's not working. God damn it. Website is brothersoftheserpent.com. You can find all of the archive shows there, the ones that don't show up in the feed anymore. Also, the Encyclopedia, the glossary of terms, the Snakeskins, which is our merchandise store. And you can find, of course, the pyramid scheme there, where you can donate to us going through the Patreon link or a link to direct PayPal donations. Also, give us reviews wherever you can, but especially on the Apple Podcasts or iTunes store. If you give us reviews there, that really helps push the show. It makes us go up in the ranks. Share the shows wherever you can. Follow us on Twitter @SnakeBros, SNKBRS. Join the Facebook group if you're on Facebook. That's run by Jordan. Thanks very much to him. Check out the Library of the Serpent, which is run by Jeff, who also runs the Discord chat. So join the Discord. You can go to the website, and there's a link to the on the right that says the Snake Pit Discord chat. Click on that, and you'll see the connect button in the little widget there. Also, History Shift. He makes all of our YouTube videos, so if you're watching or listening to this on YouTube, this is his work. Thanks very much to him, and you can follow him on YouTube or on Twitter. Just look up History Shift. Also, Pod Doodles. This guy makes doodles of our podcasts that you can watch him draw while listening to the podcast. Right now, he's doing the second one we did with Randall Carlson, episode 108. So that's really cool. So follow him on YouTube and on Twitter, Pod Doodles. And don't forget about Cosmographia, the podcast we do with Randall Carlson. Also, we have a Reddit subreddit group. So join Brothers of the Serpent on subreddit r/Brothers of the Serpent.
Before we get banned.
Yeah. Also, thanks very much to Where Did the Road Go, Uncharted X, Mike and Maurice's Mind Escape, the C Word Podcast, Grimerica, and Conspiranormal. Also, everyone check out,
I don't know where I couldn't find them. I couldn't
you have
find
a piece
them.
of paper right here.
Oh, yeah.
Brett. Yes. Snake Bro Brett JB has been making music for a long time, and he sent us links to his. So look him up on Bandcamp, right? That's where
Yep,
he is on
that's
Bandcamp.
right, Bandcamp.
He's got a new song called Catastrophe, which is about this kind of stuff. He is a Snake Bro, so everybody should go check out his music. And what you said, you were talking about the production, right?
Yeah, man, it's great. It's great production.
What was the guy's name? His engineer?
I don't know. Engineer also plays bass, maybe, and drums, probably.
Yeah. Anyway, it's well done.
Dang it.
Sorry,
bro. Didn't have the
So
website
check him out.
pulled up,
Brett,
but yeah,
just go to Brett.
Good stuff.
Yeah, look up Brett JB on Bandcamp. He said, please dox me. So we are doing that right now. So everybody should check that out. And there's one other thing. Gavin, dude, I got your emails. Too late to put them on this show, but they are definitely going on the next one, bro. Thank you so much. And we'll talk to you guys next week. This is our favorite time of the week, even though it was 2 days this time.
Yeah. Made 2 days great.
So we love you guys. We always have.
Always will.
Good night, Adamu.
Get back to work.
That's right. More Bigfoot sex.